Antikythera Mechanism, the mechanical cosmos. The sea had already chewed it to lumps when the sponge divers brought the wreck up in 1901. They tossed bronze statues and amphorae into daylight. The lump that mattered looked worthless until it split. A gear wheel flashed under museum light, teeth as fine as a watch. Stakes first. If we're right about this device, it pushes precision mechanical computing back into the 2nd century BCE, maybe earlier. Not water wheels, not mill cogs, differential gearing, predictive astronomy, eclipses, cycles, games, calendars, all encoded in bronze. If that's true, the simple ancient story dies, and so does the comforting straight line of progress. What actually happened next is a tangle of people and patience. Decades passed with the fragments mislabeled and misunderstood. The inscriptions were almost invisible. Then imaging changed everything. Microfocus X-ray CT peeled corrosion away without touching it. Gear outlines emerged. Tooth counts snapped into ratios. Researchers began to see not a curiosity, but a machine with intention. You could crank it and watch the sky move. On the front, dials for the sun and moon, and based on reconstructions, the known planets: Mercury, Venus, Mars, Jupiter, Saturn, each with its own tricky motion. The moon's non-uniform speed wasn't hand-waved. It was modeled mechanically through a pin-and-slot epicyclic train. On the back, spiraled scales for the metonic cycle, Saros eclipse cycle, predicting when the sky would darken, and even a callippic refinement. There's evidence of an Olympiad indicator. This wasn't decorative. It was a compact cosmos you could hold. Human moments anchor the story. The sponge divers surfaced sick from the depths, hauling history they didn't recognize. In the mid-20th century, Derek de Sala Price took a big swing. He argued for a complex gearwork that many doubted. Years later, Tony Freeth and his team used high-resolution scans to decode inscriptions and propose a full kinematic model. They weren't inventing romance. They were counting teeth, matching cycles, and testing whether the math drove the metal. Each tiny inscription, each slot, each shoulder on a gear had a purpose. When a modern watchmaker builds a replica and it bites, you feel the mind that designed it. Here's the impact ripple. One artifact implies a workshop. A workshop implies a culture of toolmakers, measuring systems, and teaching. You don't jump from hammering shields to cutting 1.5mm gear teeth with precise counts overnight. That means lost lathes or equivalents, jigs, and a knowledge chain, artisans who knew how to engrave scales on curved plates and align axles in tight tolerances. Once you accept the mechanism is real, you have to ask, where are the siblings? Where's the scrap? Where are the manuals? Suppression is quieter here, more bureaucratic than malicious. For decades, the device lived as an oddity, told in a paragraph under a glass case. Scholars who pushed its complexity met raised eyebrows. Access to the fragments was limited, imaging time was scarce. Without high-resolution scans, arguments devolved into hand-waving. Gatekeeping didn't look like censorship, it looked like paperwork. Meanwhile, the public conversation filled with either wild speculation or yawns. Both outcomes keep the device inert. Let's be clear on facts versus fantasy. It did not prove ancient space travel. It did not require lasers. What the evidence supports is more startling and more human. Hellenistic engineers, using careful craft, built an analog computer to predict the sky, drawing on Babylonian cycles, Greek geometry, and practical mechanics. The error bars are present. Fragmentary pieces mean some reconstructions may be refined, but the core is solid, predictive, geared astronomy. And then there's the workshop question that won't go away. Workshops make families of objects. If this was a one-off gift, it still needed a shop to birth it. If it wasn't, then somewhere in silt or in private collections, other devices wait, perhaps burned down to stains on wood, perhaps corroded to silence, perhaps miscatalogued as gear-like fragment. This is where the suppression mechanism intersects with loss. When archives burn or empires fracture, machines go first. Metal gets melted. Inscriptions get scraped. Skills die when apprentices stop showing up. But consider what nobody knew at the time. The mechanism's gear trains indirectly point to a wider gear culture. Elsewhere in ancient China, differential concepts appear in the south-pointing chariot. In Alexandria, mathematicians wrote methods we only glimpsed later through palimpsests. The idea that complex machines emerged in a vacuum feels thin. Meanwhile, comparison with later Islamic astronomical instruments, the astrolabe tradition, the Zij tables, suggests an ongoing conversation across centuries, languages, and ports. The Antikythera mechanism isn't a lone miracle, it's a survivor. On the ground, the stakes get personal.